This is the third exercise for logic chapter. But before that, we have completed the whole chapter, that is a differentiation. That is very important. M2 is very important. And I hope that all of you are doing very good practice for the mathematics M2 and the differentiation. If you do the hard work, solve each and every example, then you will be expert in M2 and you will score good score in the board exam. When I will complete this logic chapter, I will start integration, that is an indefinite integration. Then and then you can distinguish between the differentiation and the integration, and the completion of that I will start the definite integration, and then application of the differentiation, application of the integration. Now let us start the mathematical logic exercise 1.3. It's very simple and easy. I hope that you will understood all whatever that I am explaining here. Now let us start. Quantifies and quantified statements. What is the meaning of the above two words? Look at the following statements. The P statement is there exists an even prime number in the set of natural numbers. Yes, there is even prime number in set of the natural number, and that is a 2. We know that. Now Q statement states that all natural numbers are positive. No doubt. All natural numbers are positive. Now each of them asserts a condition for some or all objects. That is, first is there exists means some, and second is all natural means all objects in a collection. There exist and for all are called quantifiers. The word there exists and for all are called the quantifiers. These are the quantifiers. There exist and for all. Next, these are the quantifiers. There exist and for all. This is important. This is a quantifier. In between them, what is called there exist? What is called for all? That is, there exist is called there exists called extension quantifier. There exists for the extension quantifier, and it is denoted by, now see this symbol, that is, it is an opposite side of the E. There exists, this is the symbol. When you learn the mathematics in after 12th standard, that is F5 BSc, S5 BSc and TY BSc, we use this type of the symbol, that is there exist. This is the symbol there exist. For all is called the universal quantifier and is denoted by this symbol. This is the symbol for all. Statement involving quantifiers. Statement involving quantifiers are called quantified statement. Sometimes there is a problem in writing with my tab. Statement involving quantifiers are called quantified statements. Now, what contain in quantified statement? Every quantified statement, every quantified statement correspond to, there is a collection, that is, there exists an even prime number in a set of natural number. That is, this is a set of natural number is a collection, and then what is a condition? Prime number is condition. Every quantified statement corresponds to collection. There is a collection and a condition. Next, in statement P, the collection is set of natural number, and the condition is being even prime. Even prime. Now, what is the condition in the statement Q? What is the condition in the statement Q? Now we'll see that condition. Now see this. The statement Q has the condition all natural numbers are positive. What is that? All natural numbers are positive. All natural numbers. This is the collection, and positive is the condition. Now let us go. Next is now the next is a statement quantified by universal quantified is true if all objects in the collection satisfy the condition. All objects must satisfy. Therefore, we say that every means all objects satisfy the condition. That is, all natural numbers are positive. Every natural number satisfies the condition, and therefore its truth value is t. And if is false, and it is false if at least single object, that is a one object in the collection does not satisfy the condition. A statement quantified by extensional quantifier is true if at least one object in the collection satisfies the condition, and it is false if no object in the collection satisfies. Now next is duals. We use letters T and C, that is a tautology and the contradiction, to denote tautology and contradiction. Respectively. Now, if two statements contain logical connectives like or, and, and the letters T and C. Then they are said to be dwells of each other. Dwells of each other. If one of them is obtained from the other by interchanging or with and T with C. The dual of P or Q is P and Q. The dual of T or P is T is that is the tautology is replaced by contradiction or is and. T and P is a C or P and this. Now next, this is very important. You must learn these formulas. That is the negation of compound statement. First, negation of conjunction. That is the negation of P and Q is equals to negation of P or negation of Q. What's happened here? When we apply this negation for this AND statement, this P become negation of P and this AND will become OR negation of P. Next, AND will become OR and the negation of disjunction negation of disjunction, that is the negation of P or Q, negation of P and negation of Q. In this case, this OR become and each P and Q, both of them becomes negation. Now negation of amplification. This you have to remember. This is very important. Negation of implication. That is negation of P implies Q is equivalent to P and negation Q. This is important. You have to remember this. Many times the student forget this. That the negation of P implies Q is equivalent to P and negation Q. And the negation of the double implication. Negation of biconditional. That is the negation of biconditional is P double implication Q is equivalent to P and negation Q or Q and negation P. It's very simple. Next is If P implies Q, converse, inverse and contrapositive. If P implies Q, then Q implies P is called the converse of, is called the converse of the above statement. If we have the statement, what is that? P implies Q is a statement. Then what is its converse? Q implies P. P implies Q is a statement, then its converse is the Q implies P. This is called the converse. म्हणजे उलट करणार आपण Q implies P. What is it called? The next is inverse. That is the negation of the given statement. Now see this here. Negation of the given statement. P implies Q. This is the given statement. If we apply the negation of P implies negation of the Q is called the inverse. That is negation of the inverse. What about the converse that you all learn basic property converse? That is Q implies P. This is called the converse. Inverse is negation of the given statement. And what is the last? Contrapositive. Contrapositive is a negation of the converse. That is the negation of P implies negation of Q implies negation of P. It is called the contrapositive. Is called contrapositive. Now, contrapositive. Now see this here. This is very important. If there is a statement P implies Q, then Q implies P is a converse of the given statement. Negation of the given statement is called the inverse. You remember, तुम्ही पाठ करताना असंच learn करा. That is Q implies P is called converse. Negation of the given statement is called the inverse. Negation of the converse is called the contrapositive. Now we'll start the exercise 1.3. The set if A is equals to in curly bracket 3, 5, 7, 9, 11, 12. Determine the truth value of each of the following. Now the first is there exists exchange here. X belongs to A such that X minus 8 is equals to 1. There exists X belongs to A such that X minus 8 is equals to 1. Now if we solve this, you will get X minus 8 is equals to means that is X is equals to 1 plus 8 which is 9. Yes, 9 exists in set of that we have given. Therefore the truth value is capital. Truth value. Next, second, for every X belongs to A, X square plus X is an even number. Is an even number. Yes, if we try for all the numbers, that is 3, 5, 7, 9, 11, 12, the square of the number, if we add it, all are even number. Therefore, its a truth value is a capital T. You can verify it. Third, there exists x belongs to A such that x square is a less than 0. It's not possible. Square of all numbers are positive. They will never less than 0. Therefore, the truth value of this statement is there exists x belongs to A, and if we make it a square and it is less than 0, means it's negative, but the square of any number is positive. Therefore, it is not less than 0, it is positive. Therefore, this truth value of this statement is a false. Next, म्हणजे x मध्ये a मध्ये असा कुठलाच एलिमेंट नाही की त्याचा स्क्वेअर केल्यानंतर तो शून्यापेक्षा लहान असणार आहे. Is there exist? No. Therefore, its truth value is false. Now, next is for every x belongs to A, x is an even number. म्हणजे A मधले सगळे एलिमेंट्स हे इवन नंबर आहेत. Is possible? It's not possible. Because it contains 5, 7, 9, 11, 12. These are the odd numbers. For every x belongs to A, x is an even number. It's not possible. Therefore, its a truth value is false. For every x, it's not possible. Only 12 is possible. 3, 5, 7, 9, 11 are not even numbers. Next is, there exists x belongs to A such that (3x plus 8) is greater than 40. The writing board is not stable. There exists x belongs to A. Is there exists x belongs to A such that it satisfies the condition? Now, which number will satisfy that condition? Yes, there exists a number. We have the number 12, 11. Its a truth value is a T. Satisfied. There are the elements. Which are the elements? 11 and 12. 11 into 3, 33 plus 8, greater than 40. 12, greater than 40. Next is, for every x belongs to A, 2x plus 9 greater than 40. What is a small number? Small number is 3. 3 into 2, 6. 6 plus 9. That is a 15, which is greater than. Yes, it's a truth value is a T. For every x in A, 2x plus 9 greater than 40. म्हणजे आपण लहानात लहान नंबर घेणार आणि तो किती घेतला मी 3 घेतला. 3 into 2, 6. 6 plus 9, 15, which is greater than 14. नंतर मग 5 आहे. Yes, it will be true for every x in A. This is possible. Therefore, it's a truth value is a T. Next is question number 2. Write the duals of each of the following. Write the dual of each of the first is, we have seen that and is replaced by or is replaced by and T is replaced by C and C is replaced by T. Very simple dual. This is the dual. This or and or. This is P and Q in bracket. Q and R. These both are the and they are replaced by R. Third, P or Q and in second bracket R or S. Now in this case also Q and P or R and S. This is the door. It's very simple. And is replaced by or is replaced by and, T is replaced by C is replaced by T. Then we get the 12. Now here P or negation Q. Next is fifth one. Negation of P or Q and negation of R and S. This is and again or S. Now the next is negation of P and in bracket negation of Q and in next bracket P or Q and negation of R. Only see that whatever that there is the place where there is and replaced by or is replaced by. This is the simple way to find out the difference. Next is seventh. Again, this is simple and is replaced by or is replaced by and. Next is eighth one. C, that is a contradiction. Then it will be C is replaced by T. C or in bracket P and in bracket Q or R. Now this C is replaced by T and in curly bracket P or in bracket Q and R. तुम्हाला त्या व्हिडिओचा स्पीड जर फार कमी वाटला तुम्ही स्पीड वाढवू शकता. हा नॉर्मल स्टुडंटसाठी मी घेतलेला आहे. कॉमर्सच्या विद्यार्थ्यांना देखील लॉजिक हे चॅप्टर असते. It will be helpful to that students also. Now next is the negation of P or in bracket Q and R and T. Now negation of P and Q or R or C. T is replaced by C. Tautology is replaced by contradiction. Now the 10th. P or Q bracket complete C. Now next is P and Q bracket complete again and T. Very simple chapter. Write the negations of the following. Write the negations of the following. First, x plus 8 greater than 11 or y minus 3 is equals to 6. Now this is important. X plus 8, as there is a greater than 11, then what's its negation? It's a less than or equal to x plus 8 less than or equal to 11. Now see this here, x plus 8 less than or equal to 11 and or is replaced by and x plus 8 less than or equal to 11 and y minus 3 is not equals to 6. This is the negation. Now second, 11 is a less than 15 and 25 is a greater than 20. Therefore, less than, then it's become greater than or equal to. And become or 25 less than or equal to, greater than become less than or equal to. Third one, quadrilateral is a square if and only if it is rhombus. Now first of all, we write the statement P, quadrilateral is a square. Second, Q quadrilateral is a rhombus. Now the negation of the double implication. First is negation of the double implication, the P and negation Q, or Q and negation of, that is, the quadrilateral is a square, but we may write there and but not rhombus or quadrilateral is rhombus but not a square. Next is it is cold and rainy. It is cold and rainy. Now there is and it is not cold or not rainy. Very simple. We can have the negation and is replaced by or. This and is replaced by or and not cold, not rainy. Fifth one, if it is raining, then we will go. If it is raining, then we will go and play football. We will go and play football. Now this P, it is raining. q, we will go and play football. Now we have the statement P implies Q. Then its a negation is P implies Q, negation is P and negation Q. Therefore, it is raining and we will not go. And is again replaced by or. We will not go or not play football. Sixth, root 2 is a rational number. It's very simple. Root 2 is a rational number. Root 2 is not a rational number, and we know that it is a irrational number. Next, all natural numbers are whole numbers. All natural numbers are whole number. Negation of all. Some natural numbers are not whole number. Next is 8th one. There exists n belongs to set of natural number. N square plus n plus 2 is divisible by 4. Sorry, for all, sorry, here is a for all, I read the direct answer. For all n belongs to set of natural number, n square plus n plus 2 is divisible by 4. Therefore, its negation is a there exists n belongs to set of natural number, n square plus n is not divisible by 4. Next is, there exists x belongs to natural number such that x minus 17 less than 20. For every x belongs to set of natural number such that x minus 17 is greater than or equal to 20. Now the next is question number 4. Write the converse, inverse and contrapositive of the following statements. Write the converse, inverse and contrapositive of the following statements. If x is less than y, then x square is less than y square. xy belongs to set of real number. I want to write converse, inverse and contrapositive. Now P is x is less than y and Q is x square less than y square. Given statement is P implies Q. Then what is its converse? Q implies P. This is the converse, and if we write then it is written as if x square is less than y square, then x is less than y. Inverse that is the negation of the given statement. We always define what is the inverse. The negation of the given. What is the given statement? P implies Q. It's a negation. Therefore, what is the negation? That is a P, which is x is less than, x is greater than or equal to y. If x is greater than or equal to y, then x square is also greater than or equal to y square. Contrapositive. The contrapositive is a negation of the converse. You remember this. या पद्धतीनेच तुम्ही ते लक्षात ठेवा. Negation of the converse is called the contrapositive. Negation of the given statement is called the inverse. And converse is easy, that we know. That is an if x square is greater than or equal to y square, then x is greater than or equal to y. This is the contrapositive. Second, a family becomes literate if the woman in it is literate. P. The woman in the family literate. Q. A family becomes literate. Now the given statement. P implies Q. Woman is literate. Family becomes literate. Now it's a converse. Is Q implies P. Therefore it is written as if family becomes literate, if family becomes literate, then woman in it is literate. Now the inverse. Negation of P implies negation of Q. That is the negation of the given statement. If woman in the family is not literate, then the family does not become literate. Contrapositive. Negation of converse. The negation of Q implies negation of P. If the family does not become literate, then the woman in the family is not literate. Third statement. If the surface area decreases, then pressure increases. P. Surface area decreases, Q. Pressure increases. Now P implies Q, and its a converse is if the pressure increases, then surface area decreases. Now the inverse. That is the negation of the given statement. Negation of the P implies negation of Q. Negation of P implies negation of Q. If surface area does not decrease, then pressure does not increase. contrapositive. Then the negation of the converse. Negation of Q implies negation of P. If pressure does not increase, that is this is. If the pressure does not increase, my screen is not stable, that's why you can understand this. If the pressure does not increase, then the surface area does not decrease. Now the fourth one. If voltage increases, then current decreases. Now the first statement is voltage increases, current decreases. Now the converse, Q implies P. If the current decreases, then voltage increases. If the current decreases, then the voltage increases. Inverse, negation of P implies negation of Q. If the voltage does not increase, then current does not decrease. And last is contrapositive. That is a negation of Q implies negation of P. If current does not decrease, then voltage does not increase. And in this way, we have completed the exercise 1.3. I hope that you would have understood all the problems, whatever that I had explained. Again, I will show you the all whatever that I had written, the notes. See this here within a 1 minute. This is the exercise. When I write on that my digital board, that screens moves ups and downs. Therefore, now you can write down here. And in this way, we have completed the exercise, and we will see in the next video. Till then, goodbye.